This is the Amp Hour Podcast. Released February 4th, 2018. Episode 378. An interview with Jason Kridner and Robert Nelson. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And this is Robert Nelson from DigiKey.
And Jason Kridner of Texas Instruments and BeagleBoard.org.
Welcome, Beaglers. How are you guys doing?
Excellent.
Great, nice to talk to you.
Jason is a past guest. That was, a long time ago. I think in the double digits of the Amp Hour. So it's been too long since we've talked to Jason on the show. Obviously, we've talked since then. And Robert, I think you're our first DigiKey guest.
Yep, first live DigiKey guest.
Yeah. Do we have some dead ones or? Ooh, spooky.
Twitters.
All right. Okay. Cool. Yeah. So welcome. Today we're going to be obviously talking about the BeagleBoard project. Is that the right thing to say? The BeagleBoard project? Is it still BeagleBoard.org? I see that stuff everywhere. What do we call it these days?
So we're both board members at the BeagleBoard.org Foundation. The community, I guess, would be called BeagleBoard.org since that's the website and, the BeagleBoard community. But, people call it BeagleBone a lot because that's the most popular board.
Oh, true. Yep. Okay. Cool. Well, that's great. And we were talking before the show, too, and we are coming up quickly on the 10-year mark of Beagles, which is pretty crazy to think about, actually.
Isn't it? It's pretty exciting to me.
So what are in the plans for the 10-year mark?
Plans?
I mean, come on, you got to have some celebrations or like a birthday confetti, cake. I don't know.
We've done cake in the past. It's I think that we don't know what we're gonna do yet. Honestly,
puppies for everyone, maybe. How about that?
Just
you get a beagle and you get a beagle.
I love it.
Yeah. little messy.
Don't do it WKRP style. No, throwing them out the helicopter.
Right. Well, okay. So we've talked to Jason before. Obviously, people can go listen to that one. Let's get a little bit about Robert, especially because you're working at DigiKey, but you're also on the BeagleBoard board, the BeagleBoard board.
Yeah, the board of the Beagles.
Okay. Yes. So why don't we get a little bit of background on you? So what is your story? How did you get into this all?
For me, it just started when TI announced the product, and we actually advertised it in Thief Falls at the local radio station. So I picked up the first board, and I noticed it was running an Angstrom at the time, and I don't like this, and so I ported Debian to it. And then a couple days later, I went on the mailing list hey, here's how I get Debian on this board. And
right.
10 years later, look what happened.
Yep, stuck with it ever since.
Yep.
So, you said it was Angstrom to start with. I'm trying to think. I was trying to think back of the first time I saw a BeagleBoard was probably one of the early ones, but that was what was that first one too? It was it was $150 and it was a bigger processor, right?
Yeah, it was $150. It had 128 megs of SD-RAM and I think 128 megs of NAND. And the guys at Angstrom got all that to fit on there, including a desktop. So it was very well done.
That's cool. Right.
Yeah, the first distro we actually brought up on the original BeagleBoard was Maemo, which I think most people remember, but it was the operating system. It was Debian packaged base, but it was cross-built into this crazy tool called Scratchbox, and but it was for the tablets for these Nokia tablet devices. Linux-based tablet devices.
Okay, kind of like how all the all-winter parts are going on everything these days, and they're super cheap. This was targeting for the tablets as well, right?
Yeah. So one of the same processor, the OMAP 3 processor that was used on the original BeagleBoard, was also used in the Nokia N900 tablet.
Okay.
And so that was the first one.
Everybody remembers that one, huh?
Who's Nokia? What? No.
Right. Exactly.
Only at the time the world's biggest mobile phone maker, but
Right. How the greats have fallen.
Things change, right? So we and then I started playing with Gentoo, which was my favorite Linux distribution. I like because everything builds from source. I know I can always continue to move forward with that.
Right. What a friendly open source way to do
You
things,
know,
right?
friendly is friendly for what, right?
Yeah, noobs. Come on.
Yeah, well, noobs are very important, and being friendly to noobs is extremely important. And I think it comes to respecting people that are experienced as well. If you're nice to noobs, then it's an easy on ramp for experienced people. But sometimes, what people want to do can't be easy when you try to oversimplify things. And
Sure, I do agree with that. Although we will get into that's some of the future plans, so that'll be an interesting contrast as well, I think.
Yeah.
So what does it take to? I mean, I have to just kind of plead stupidity here, as I often do. But like, if one is going to target so it's like you see a new board, it's got Angstrom on it. You're like, I want to put Debian on it. Like, what is the steps you have to take in that case, Robert?
In that case, I had to figure out how to build a root file system from Debian.
Okay.
And at the time, I think DBootstrap existed. I just didn't know about it. So I started with.
Sorry, I'm going to probably stop you a couple times here, but what does that mean?
So DBootstrap is an internal tool in the Debian system that allows you to generate a base image from a set of optional options. So it's a very complex tool.
Okay.
At the time, way back this time, Debian wasn't really built for cross-compiling, and there weren't powerful enough ARM systems to actually natively build all of the ARM packages.
Interesting. Okay.
Debian was a little bit different. Debian got to ARM much faster than Ubuntu did because they were targeting embedded devices much earlier. But it was just there are very limited number of packages that you could really cross compile. Did you cross compile everything, Robert?
At the time, I natively built all the kernels, even on the 120 megabyte original Beagle. So it only took about 6 hours to build like a 2.6.28 kernel.
So that means that it was actually being built on the device itself.
Yep.
Versus
at the same time, I was testing
externally.
the stability of the device, so that kind of came in handy. It's like if it survives a 6 hour build, it's got to be good, right?
But how many packages did you have in your root file system? If were you natively building the packages too?
At that time, I wasn't rebuilding the packages, so it was just the kernel at that time.
Okay, there was enough ARMHF packages, or I guess it wouldn't have been ARMHF at that time.
It was even worse. It was Etch, which was ARM, which was EABI3.
Yeah,
I'm going to have so many links to try and find for people too. So I'm going to be kind of on the outside here, I think. I'm sure these two could talk all the time about this, or for hours about this stuff too. Okay, so I guess one of the things that I always wondered about, like, so say I have a brand new, maybe not the RISC-V, but like just say there's a new chip, the XYZ chip that comes out tomorrow, right? And I want to go do what you did. So the XYZ chip has Angstrom on it, and I want to go put Debian on it. How is it that like the whole system even knows what's available within that processor? Is it like there's libraries that are already built from the vendor that gets pulled in?
The power of the Linux kernel.
It's power of mainline.
Well, I'm gonna plead ignorance on this stuff because I guess I don't quite understand that either. So I mean, the power of the Linux kernel, sure, but like, what does that mean?
To abstract all the hardware. It doesn't. But it does a pretty good job of abstracting all the hardware. So if a package needs to write to a display or read something off of I2C, read a keyboard, have a network, send packets over a network device, the Linux kernel handles all that. So the first part is the first part's actually the bootloader. So you have to get a bootloader up that knows how to load the Linux kernel. And then you have to have a Linux kernel that will run on that architecture board.
So who writes that piece that's from the... So is it because you need to rewrite the kernel? Because I know this is what Robert does now too, is like some of the kernel stuff. But like for the kernel to understand what is actually available there needs to be some kind of like interface, right? Or someone has to write that... Is it just drivers, or is it other stuff, or what is it?
It's a lot of low-level drivers, and a lot of times it starts with either just a serial port that magically works, or you have a JTAG that you can plug in.
Okay.
And a lot of times it's just, you have to find something similar, It's like, okay, what do we change between these boards? And you kind of poke around until you get something booting. And usually once you get the console, you're golden. You can start doing a lot of stuff.
And we're assuming we're already on the CPU architecture at that point, right? Because if you're talking about RISC-V versus, ARM,
right, versus
ARM
ARM7 or whatever. Yeah, right.
Yeah.
Right. So so that's another piece then is so what is the architecture piece then? So like now
first you need
you're
a
switching
compiler.
between
and for Linux you need the GCC compiler. You can, at least for upstream, you can compile the Linux kernel with other compilers like LLVM or a number of different commercial compilers as well. And a lot of times you bootstrap them with some type of commercial compiler, but then you need some compiler support for back in the early days of Beagle, getting the compiler support into mainline GCC for the ARM v7 architecture was actually a big part of what we were doing. We paved the way for a lot of people with what we did with Beagle. Because
right, because it's these projects that, like why would commercial companies care about it? They're not seeing any direct benefit of it, right? And it's like probably some off-brand or smaller architectures, right? I mean, if you're targeting tablet type stuff.
Yeah, at the time, Nokia helped out big time too, because they run the same architecture on their phones. They needed GCC because their OS was based on Linux, and so they needed it too. And they had product to move.
And they had a great community. The Maemo community was really strong. And we just poached it.
Yep. Yeah, especially with their N850 phones. I mean, it was one of the first tablet phones that was like a tablet but a phone in the 90s, and
you can actually run your own code on your phone. And you weren't locked out. You
talk about a way to get the geeks involved, right? I mean, like,
well, even today on the mailing list, people are still porting kernels to the N900 series. So that was a single core phone that came out in the early 2000s, and they're still pushing mainline.
And there have been a number of open phones that have been built based on the BeagleBoard that are still supported. And, we have folks that continue to do kernel development because of that. So it's the Golden Delicious one comes to mind, the OpenMoko.
I remember OpenMoko, yeah. I remember one of my old coworkers was super excited about it, and then it just kind of... It didn't disappear, but it's just it didn't get the hype. Obviously went elsewhere.
It just took them a long time to get everything done.
Well, there's a lot to do.
So,
I think at one point there was an adapter for the BeagleBoard XM.
Yeah, it actually plugged into the phone.
Yep,
it was this monstrosity, but they've moved on since then. They're still using. They're still using a derivative of that.
So, and when you say BeagleBone or BeagleBoard rather, that's the old form factor. I'm trying to remember. It was like what, like 3 or 4 inches.
The original I think was 3.1 by 3.0 inches in inches, and then the XM was 3.25 by 3.25. We had a little bit bigger because we put a 4-port USB hub and Ethernet, the USB hub-based Ethernet.
Well, there's been this continued convergence too, right? So like as more people came from the Arduino ecosystem, wanted more power there. Obviously, the size of the parts have all been shrinking. You guys have been pulling off, certain peripherals over time as well.
And adding more.
I remember like the first one. Well, yeah, adding more too, but I just mean that like I remember the number of ports in the first one. It was like more like a mini ATX computer than it was like what it is today, right? Or like we'll get to is Pocket Beagle, right? So like those two different things are obviously your stuff is all shrunk, and the other stuff has blossomed in terms of processing power, but they're starting to kind of converge in the middle.
Yeah. So. And we still kind of do both sides. We've got a bigger board. What's the X15, BeagleBoard X15, still kind of doing the more of like that
the high-end
desktop computer replacement. What's that, like 4.25 or something square? I don't remember.
Okay.
I'm looking at one, but I don't know exactly how big it is.
Right. It's like commercial, but it's like like a commercial computer that people might want to write or borrow code for or whatever. So
yeah, it's good.
But let's get back to the compilation stuff too, because that's interesting. So, okay, so you're at that point where you have the kernel, you have the compiler, like you said. What next? Is it like you're like, so then the kernel's like, well, I don't work with A, B, and C. That the display driver, I'm never going to talk to that thing. I'll never talk to the USB. Is it like at that point you start kind of going down the list, or
we start going down the list like what you need first, and it's like, what do I really want from this project? And you try to get that thing working first for you.
Well, now
Okay.
most of the so we've got so much working now in sort of a baseline that when people do derivatives of a BeagleBone, right, for the most part, all they have to do is write this configuration text file called the device tree, and they've got a new board.
And so that would just be like adding on. So if I want to add a new chip on there, it's on the SPI bus or something. Basically, just need to change the device tree to add that new chip on the SPI bus, or
Or even on-chip peripherals. A different derivative of a similar processor, but it's got different on-chip peripherals. If you're adding something to a SPI bus, exactly, you just specify what you've connected to that SPI bus in the device tree. And I think because how many different? There's like 20 different Beagle bones now. Robert, do you know how many we have out there?
There's a lot there. There's at least 10 to 20 derivatives. There's 10 or 20 direct copies with a different name. There's tweaks. So
some with Wi-Fi on board, some with SPI flash on board, some with different long distance radios, or there's a number of them with different speed Ethernets. Different.
So what makes a BeagleBone a BeagleBone or BeagleBoard a BeagleBoard? I suppose. What is that? What makes it qualify now? Is it just using the package?
There's obviously the trademark.
Well, obviously. Jeez, Jason, come on.
But I think it's really just from a technical standpoint, it's just the ones using the AM. The TI AM35 processors, 335X processors, kind of the base for it being a BeagleBone, where all you have to do is kind of change the device tree. But really just interacting with Robert mostly just to try to make sure that when he creates,
if he gives you the thumbs up, he is the Beagle maker.
If we want to run his distro images, right, then there's stuff that you have to make sure that you've got things going into his package build so that it'll boot up and run on your board so we can all run the same images.
Right. Well, I guess so. That's another question then too. So you mentioned the AM35XX, right? So that's the TI part that's on all these things, and now the what's they're called, Octavos, packaging those into their thing as well. So it kind of pulls more in, and we'll talk about that. But if I was gonna try and port the Beagle image to something new, right? What would be a close thing? Obviously, there'd be a lot of wailing and gnashing of teeth, but what would it take then to actually go and do that same thing?
The biggest thing, as long as you got U-boot working and the kernel, we could pretty much package it all in the same image.
Really? Okay. And so when you say it's in the same image, then moving forwards, if I download the image tomorrow and it's got support for a new board, like Jason's stuff, so Jason makes a new board, you update the image, I download the new image tomorrow. Does that mean it's going to still keep running my stuff, but then it'll also start running Jason's stuff?
Yep. As long as a couple of requisites are made. We're very lucky with how configurable U-boot is right now. So as long as it's an AM335 target, doesn't matter what variant it is or what it is, it can all boot off the same image. But now,
so I was actually saying outside the AM335.
Yeah, so outside the AM335, we generate for an AM5 variant, the Beagle X15. We still generate for the OMAP 36, which is a BeagleBoard XM, and that'll also work on the original Beagle. Okay. And with a bootloader change, that'll actually work with the old Panda board too. Which
cool. Okay.
Those are kind of getting hard to find nowadays.
But if you change if you need a bootloader change where the bootloader itself has to change, you essentially have to patch the disk image with a different bootloader. We can't just boot off of the exact same SD card image.
Right. Okay. Yeah, and it's almost feels like a family tree almost, right? Within the immediate family, and then the extended family, and then maybe you're the neighbor to this family or something. You know what I mean? There's a wide variety of what you could do, but obviously being closest to the center of that family tree, you're going to have the easiest time in making a new image or trying a new thing. Because I have to imagine, and I'd like to get into this later too, is as people are designing these things into commercial products or just, I think industrial stuff it's a great target for this stuff. This is a real concern, right? I mean, if I go and take a new chip, put it down on a board, I have a bunch of new peripherals that are not in any other Beagle product of any type. Then I want to make my own thing, but I also want any future improvements that y'all are making, you know, I want to be able to pull that into my new image as well, and I have to kind of maintain that over time, right?
Yep.
Yeah. The biggest challenge is if you don't submit the patches that you're making somehow back. If you want to be able to move to the new images, you have to reapply your changes.
Interesting.
So that's the biggest challenge is like, oh, you want to update, you know, move to the latest image and just run it. Well, if you didn't either isolate your changes so they just load on top, or submit them to, you know, preferably the Linux mainline or U-boot mainline, you know, we won't pick them up. Now, if you get them in the mainline, we'll pull them down into our images. We're always you know, tracking the latest Linux kernels, right? So we've got like the stuff we're doing on a regular basis is on the 4.14 kernel. So I don't is 4.15 out yet?
Yep, 4.15 went out this morning, and 4.16 already opened up. So
okay.
Yeah, well, we do a lot of backports. So right now we got 3 main kernels we're working on: 4.4, 4.9, and 4.14.
Wow.
Yeah, the goal was a transition to 4.9 pretty quickly, but the 4.4 is just too darn stable.
Oh, got it. Okay.
And so
yeah, it's interesting. So I mean, like, and maybe for people that have never, people like me. So like, if I wanted to go and start compiling my own stuff tomorrow, right, to make my own image tomorrow for a new, maybe not even for a new thing, just I want to go try it out. I want to go try it out. I want to go see if I can just do this. Where do I start?
Buy a BeagleBoard X15 because you need a nice fast ARM target or ARM system to do your building on. So rather than trying to figure out how to cross-compile it, go buy yourself a nice BeagleBoard X15 and then download the github.com/BeagleBoard/image-builder, which is a repo that Robert maintains that has all of his scripts that he used for building the images. So you run that script, it actually spits out a disk image, or about 10 of them, I think. I don't remember how many, well, depending on what script you run. But and then try booting that image and then start changing the script to make it do different things. But it's all just pulling from the mainline Debian repos and then a set of repos that Robert maintains with various customizations.
And so when you say like, so the cross-compiler thing then you're talking about is it's easier to build on the system it's on because it's already targeted at all the things you need to have, all the peripherals, whatever.
All these different packages have a lot of them build in a way that kind of probes the system that it's running on. So it needs to be running on something kind of that looks pretty similar in terms of architecture. All these other there's a lot of fancy systems like the Yocto project that try to fix all that. It turns out for all these packages, it's a lot of work to fix all these packages to build to actually work in it.
Make it look like something else when you could just run it on the thing you're running on.
Yeah,
right?
and that's why we made the shift. The ARM systems are fast enough. We'll just assume that we can build natively and try to move quickly as possible without having to try to fix all these packages. Now, there's a lot of other reasons why Yocto is great and doing all this fixing, you know, provides some proof point, you know, that you kind of own your own destiny a little bit. But I think our shared destiny is large enough with the Debian world that we can have a lot of fun stuff going on.
Right, because then you start to pull in other software tools that are available. A lot of the people that are getting used to Ubuntu, not getting used to, but are regularly using Ubuntu, it's just such a big project these days too, that it's, you know, so you get a lot of that crossover.
Yeah, and if you want to, if you want to cut and paste Stack Exchange messages, you know, posts.
You know me well.
So for the cut and pasters, this is the way to go.
And so, Robert, what are those? I mean, what do those scripts look like? Are they? Didn't see? I guess I don't even know. I'm so out of my element, guys.
It's mostly in Bash.
Okay, Bash. Yeah, that makes more sense. I'm so out of my element. Sorry.
Yeah.
Is it like code or?
It's a very C-like Bash.
Resistors involved?
You know we do hardware too.
I know. We'll get to that.
It's essentially a 1,000-line Bash script file. They're all terminal commands, so.
Okay.
So it's just scripted terminal.
So I could type them in one by one, you're saying?
Yeah.
If I really wanted to learn, I could just...
You could.
Right.
Or you could just put the -X at the top and then run it, and it'll show you all the commands it's doing.
It's probably better. Yeah. Okay.
But it's just it's just a script to automate run in DBootstrap and DBootstrap and a bunch of other scripts that we do. So it's just to make your life easier.
I mean, are people doing this? I guess that's another important question. Is it worthwhile for people to think to do this, I suppose? Other than the learning?
We do have some people doing it, and they do ship images based off of it. So I've got a lot of patches over the years from people like, well, I tried this with this, and this is the workaround I needed.
Again, I think the custom hardware thing, like, and especially if it's succeeding, right? I mean, if your project's doing well, the Beagle project rather, it's like, it's putting tendrils in all these parts of the electronics economy, and shipping more parts. That's what TI wants to, and yada yada yada. That's like, yay, open hardware. So yeah, that's good. But then this is kind of that other piece that I think I usually don't think about, right? It's like, oh, of course it would work, but this would scare me off, to be honest. That's good.
You shouldn't have to do it, though. Hopefully this is not for you doing, you decide you want to make your own computer. All the problems that you brought up shouldn't be the ones that scare you off from, should I go and build my own computer?
What should scare me off, Jason?
Well, I think if
so you make hardware, huh?
So you should have some idea of what signal integrity means. Some idea of match trace links. I've done something with microcontrollers before.
Sure.
But if you've made microcontroller based computers, you should be able to use something like the SIP that's on the Pocket Beagle to go and make your own Linux computer. And if you don't want
differential
Linux, don't
trace
use
is
Linux,
now
but you
available
could
in
use Linux.
KiCad, So,
yeah. It's in KiCad. It's in Eagle.
I know.
It's in Upverter too, although we haven't actually verified the Upverter version.
Womp womp.
It could be hand soldered.
Yeah, that's true. Yep. Cool.
There's a good YouTube video showing how to do it.
Nice. All right, well, let's get into this. I mean, like, so obviously, I'm talking about putting stuff on boards. I've thought about it now because of the Pocket Beagle. Like there's the new part from Octavo. I think it's a great, little part. It's got a better BGA, a more accessible BGA. So what are you seeing with that? Well, first off, what is Pocket Beagle? Because I've mentioned it a couple times, but I talk too fast.
I have known to have a little fetish for mint tins.
Yeah.
So the original BeagleBone fit inside of a standard mint tin.
Can't say Altite tins. I can say it.
Yeah, I try not to. Sorry. And so Altoids also makes the smalls. I'll go ahead and since you cracked that one open.
Right. I said it first. Yeah. Right. Yeah.
But the Altoid smalls mint tin, the Pocket Beagle is in that shape because we can.
Right. I always do bring up. I'm like, it is metal, and this is electronics.
But it's a perfect for storage while it's not powered.
Right.
Yes, you can generate some static, but it's also not too hard to put some insulating material on the inside of it and take a Dremel and cut out openings and actually run it safely.
Yeah, it sounds super convenient.
It's a survival tool, right?
I think I think it's a great constraint. Engineering needs constraints, and that's one of them. And I think that the new one with the mini tin too, I think it's a great constraint. Now, I warned you before the show I was going to take you to task a little bit about this, but why don't the headers fit next to the part?
Because you haven't used the right headers yet.
Which I was excited to hear. I was excited to hear that. So you're going to send me a link to these headers? Is that right?
Sure.
What are they, like narrower headers?
So right now, and Robert may have some updates on. Right now, the headers that I know fit are actually single row headers, and you can take single row headers and just put two on each side, and they fit neatly flat.
Okay.
So you don't have to have them sticking up. Robert doesn't seem to mind using the longer leads in order to get
the
up
ones
above.
that can like plug below it. Like
But if you want to put the female headers on top, you can use the single row female headers, and they work great. But yeah, you have to put 4 of them on there. 2 on each side.
Yeah. So if people don't know what I'm talking about here, it's actually that if you use a double row, what is it, 2x18, 2x18, I think.
Yeah.
Double row. The thickness of the plastic runs just into the edge of the Octavo SIP, which is it's super close. But like Jason said, you can fit stuff in there. My solution was actually just to put them upside down. So I put them on the bottom side of the board, and then I put mail headers on the board that I was building.
Or a belt sander works great too.
There's an engineer right there.
Just need to take a millimeter off of it. So
That's right. I was thinking about doing that and just selling those. Just like a little cutout, like a small cutout. Just machine, set up a little jig, machine it out.
I just can't figure out why all of the double row headers are at least 5 millimeters wide, whereas we can find the single row headers smaller than 2.5 millimeters wide.
And they're all.
I mean, if there's anyone in a connector company, we're talking about a pure opportunity here. Obviously, the Pocket Beagle is a $25 little powerhouse, so you could sell at least 100 of these things if you make new. I said at least. Who knows? The sky's the limit, guys.
We need 2 of them, so 200.
Oh, there you go.
Yeah, for some reason, all the dual row plastic ones they're wider than they say in the spec. So the single row ones aren't.
Interesting.
It's like
okay.
They all went that direction.
Maybe just for stability. I don't know, shooting in the
Old molds
plastic or something. Oh yeah, true. That could be it. They just as they just wear down, they get wider and wider. That's very possible. Okay, so what actually prompted the Pocket Beagle in the first place?
Well, the new SIP was a big part of it, getting it smaller, and so because we can.
Okay.
So there's a for a lot of people doing teaching that they really care about having the lowest possible entry price. So we wanted to do something at a lower price point. Also wanted to do something in some ways a little bit more flexible for people, building, systems around it. You don't need to put headers on these things. You can actually just solder them straight down to a board like a module.
Yeah.
So
right. Yeah.
It makes that sort of thing simpler. There's less resources essentially used on the board because we just kind of break things out or basically. But for people doing training, they really care about the lowest possible entry point. Wanted to show off just how simple it is to make something around the SIP, give us a starting point for building other things. So we work with people doing different derivatives at different times for fun. Like the BeagleBone Blue uses the older SIP on there, the bigger SIP.
Oh yeah, right.
But
and that thing was kind of big. I mean, it is imposing just because it takes up. I mean, obviously it was as the Octavo was getting started. It was one of their first chips,
that was their first SIP.
Yeah, and but it's just it's big, but it works great. And so the Blue is the motor driver one.
It's a full mobile robot controller.
Okay.
So it's got the Wi-Fi and Bluetooth built in, but it's also got output for 8 servo motors, including the 6-volt power rail for those. It's got a 2-cell LiPo charger, balancer, overvoltage protection. It's got 4 DC motor drivers. It's got CAN bus drivers on it. It's got the 10-axis inertial measurement unit, compass, accelerometer, gyro
for doing like an upright balancing robot type thing, right?
or drones, quadcopters, hexcopters, octocopters. So it actually runs RGPilot out of the box.
Oh wow! Okay.
Building a drone out of it's pretty easy. If you want to build submarines, there's. But it's got all that stuff shoved into one board, and the SIP makes that possible. So we have a fairly application specific, and I think it's pretty broad application when you talk about mobile robots.
Sure. And you had introduced me to one of the professors doing stuff with that. I forgot his name though. You introduced me.
There's a number of them, but if you're talking about the one that was involved in defining and creating it, it's Tom Bewley at UCSD. University of California, San Diego. They've been teaching robotics classes with the BeagleBone Black and an add-on board, which is now a standard BeagleBoard.org product called the Robotics Cape. That's on its 4th generation, and they've been teaching that for robotics for years and controls there. And now we just kind of integrated that all into one board with the BeagleBone Blue.
That's great. And so, and that's like at they are working at the like the Linux level, right? So they're writing Python type stuff.
You can,
is that
yeah,
right?
if you want to use like ROS and
Okay, yeah.
Python, we've got balance code written in Python as an example. We've got Python and C examples for doing things like the balancing robot and turning the wheels, reading
Hmm.
the quadrature encoders, reading the different sensors on the board. Um, but yeah, so it's all done on top of Linux. There's a library that kind of abstracts the hardware, and some of it actually does do some memory mapping. But we've been working with folks to try to get more of that into the Linux kernel rather than peeking and poking things in user space.
Can you explain that
Yeah,
more?
so
Sorry, or
the
maybe
right
Robert can.
the right way to do things in a Linux world is to actually make a Linux kernel driver such that the kernel driver supports the hardware. So
Uh-huh.
nothing in user space should be really touching the registers, that control the peripherals that talk to it. It should all be done through drivers to be things for properly abstracted in a Linux world. Um,
Uh-huh.
so what
So people do that though because it's faster if they want to get down faster or what?
it requires less understanding of the system. It's not necessarily faster or slower, right? It just means that there's less time spent doing integration. So people bypass the Linux kernel and say, "Oh, I'm just going to memory map this peripheral," and and they'll say it's faster. What they mean is that they were able to reach their timing goals in their project faster. Um,
Uh-huh.
they may think that it means faster, but it really just means that it takes extra time to try to figure out how to put things in the kernel nicely so that um, you know your it can be maintained and the system architecture is right and it meets your performance goals. So yeah, a lot of people in the community will just memory map a peripheral and use it that way. Um, there's some firmware that There's a firmware load that comes with the BeagleBone Blue to use the PRUs, the programmable real-time units, to generate some additional hardware PW or generate some additional PWMs, not hardware, but it makes it look like it's hardware PWMs because these microcontrollers are doing the pulse width modulation, also doing things like for ArduPilot, it reads like 4 different types of remote control protocols and does auto protocol detection, and so it can read all these different remotes. The default image also uses it for one of the quadrature encoders, because I think we only have 3 hardware quadrature encoders, and so the 4th one is actually implemented in PRU software.
Okay.
And the PRUs in a lot of things, even stuff like the Lego Mindstorms, the EV3,
Mm-hmm.
there weren't enough. That uses another TI processor, the AM1808, and there weren't enough UARTs to talk to all the different things that it needs to talk to, and they use the PRUs to generate software UARTs.
Okay. Well, I'd love to talk about the PRUs, but like step back one bit to the user space versus the other stuff, because
Sure.
so. All right, I'm gonna again show my ignorance here, but like, okay, someone wants to. This is gonna sound stupid. Program a BeagleBone. So like I'm in the world of microcontrollers all day. Like anytime I'm programming anything, it's a microcontroller. So I'm writing code. It gets compiled down. It gets loaded into Flash, and then it runs from there into RAM. Blah 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 blah. Right? But like, are people writing drivers regularly? What are they doing normally?
So I'm gonna describe a board bring up and then talk about some other things. So, like if I'm bringing up a new board based on the system and package used in the BeagleBoard, the BeagleBone, like the Pocket Beagle. So I'll boot the Linux kernel, and you would just get the Flash interface working or the UART working or something else, and I'll actually boot the Linux kernel. And then when I want to like test a connection, like test the I2C, there's actually command line utilities like probe I2C, and you can do a tremendous amount of like board level system debug and development just sitting there at the Linux command prompt. You don't actually need to write any code per se. You're just going to sysfs entries and like reading a GPIO, setting a GPIO line.
Right. And so and Ken's so Ken Shura, former guest, had a really good article about doing that with the Pocket Beagle, right? So he was just blinking an LED, doing it with sysfs, right? So like just basically reading and writing.
So you can create entire applications doing things just that way, but for the nice part about new boards or new systems is it's just a way to actually make sure everything's working. And then if that's all the performance you need, just do that, right? Just do sysfs entries and stuff. But if you need more, then maybe you'd write a kernel driver. And a kernel driver is just a program that's linked against the kernel, and it can be dynamically linked and loaded. It's really not, and it has a certain API available to it. From embedded systems developer, there's not that much difference between a kernel driver and a program. All right, you just how it gets linked and run.
Well, saying that sounds easy.
Yeah. But a lot of people, just, sit there and write their Python scripts, and there's some libraries that you can use to do, GPIO, and there's extensive libraries to talk to all sorts of SPI devices through SPIDev. And, but for the most part, the hardware that you want to talk to, there's so many different sensors that Linux already knows how to talk to, and you just have to tell it what's connected and where, and the Linux driver is already there.
So this wouldn't take like a rebuild like Robert was talking about.
No.
Take even less than that.
Oh, really? Okay.
A lot of times it's just one or two lines in the device tree.
Okay. So and maybe I'm not understanding what the device tree is then. I'm thinking of like the Windows hardware manager type thing. That sounds stupid, but yeah.
That's not a bad analogy. Except you're using a text editor.
Right. Okay.
Yeah. It's essentially just a configuration file. Okay. You have a bunch of nodes in there and leafs, and you have the I2C device, and like I have at this address, I have this accelerometer, and it uses this pin for a GPIO and this pin for a reset, and so it's abstracted out very well.
And so, so if there's a new device on the device tree like that, and it already knows how to talk to that because it's an I2C, or basically you don't have any user code yet, so it doesn't even matter. It just has to know that it's there.
The kernel knows how to talk to a lot of stuff that a lot of different types of devices, and you just have to tell them that it's there. And, and then what it's going to look like say you put a gyro on there or an accelerometer. Linux turns everything into files. So what would have is you'd have some virtual files that would have acceleration in the X, Y, and Z, and every time you want to know the acceleration in the X, Y, or Z, you just read those files.
Huh. Okay, that's cool. But the piece I guess I don't understand is like, so I go to a accelerometer manufacturer website, right? And there's a bunch of registers there. Someone at some point had to write, that's the driver piece, right? Where it's basically abstracting that register set and saying, to get the reading in the X, it's at location ABCD whatever, and then it's going to push it into this file. That's what the driver's actually doing, right?
Yeah,
correct. And there's a whole subsystem for that. It's called the IIO subsystem, and they got tons of accelerometers, gyros, tons of sensors.
Really? Okay, and just based on just shared knowledge over time.
Exactly. So I think it was originally written by Analog Devices because they wanted all their ADC devices to be well supported in the kernel. And over time, it's almost every single type of sensor has been pushed into the IIO.
If somebody throws it on a phone or onto any sort of useful device, somebody's going to put a Linux kernel driver in there for it.
Oh, that's actually really nice. So I guess the reason that because this again, like the trends that I see is just this convergence. I mean, microcontrollers and Linux computers there's a whole lot of gray area these days. I mean, I know that the memory mapping is that the difference these days for full blown Linux or something like that, or
you're talking about the memory management protection.
Memory management, yeah.
So there's
stuff, yeah.
For full blown Linux, there's usually you're assuming the processor has a memory management unit, which
right.
Ideally has protected memory, right? So there's a difference between the memory map for kernel mode versus user mode. and so that the user mode can't get to other user mode programs or to the memory
so I
for the
can't go
kernel.
overwrite if my user program. I can't go overwrite the kernel's memory space and put it in the middle of nowhere. Right.
And for embedded system, how much does that really matter? But are you really?
Well, I'm going to do it no matter what. So it's just about how hard I have to try, right?
Right.
I will put that processor in a bad place, no matter what. That is my promise to you.
No, well, if you stay in user space, you'll be prevented from doing anything like that would actually shut the system down in any meaningful way.
Okay. Okay. Cool. So that's good to know. So it sounds like the default is if you're running BeagleBoard distros, you probably have access to a whole crap load of peripherals and stuff like that, which is great. You just got to go mess with the device tree, like Robert was saying. But then you actually have to go and write code for either you're writing scripts like in Python or you're writing drivers if you don't already have the kernel drivers, right? Is there any other situations in there, or is it just mostly scripting these days?
Or the third, fixing a driver.
Oh, well.
Yeah.
A lot of times there's drivers that are close, so you have a new device, it has little tweaks that need to be made. Or
Yeah, I know that I ran into a SPI OLED, that all the drivers were for like some Adafruit breakouts or some other breakouts that were different resolutions. So I had to read, I think there were like 4 or 5 different register settings that I had to actually change in the driver to get it to work at the micro Electronica's 96 by 39 OLED.
And that's kind of like, so when I think about like writing like libraries for a microcontroller, that sounds like it's a very kind of crossover-y kind of thing with just more overhead for actually talking. Well, probably you're borrowing a lot of the code that's already there for interfacing back to the kernel, but like it sounds like the same activity of like datasheet, driver listing or register listing, and then code that makes the part do what you want it to do.
And it's a lot more structured too, because you have so many other examples and so many other libraries inside the kernel that you have to deal with.
And if somebody wrote it for an Allwinner or the Raspberry Pi or whatnot, because it's all abstracted into Linux, we just use the code.
Oh, really?
Yeah, it just works. I mean, it's using the SPI driver, so it just works. Or yeah.
So it's like ad hoc standardization without the guarantee for standard. Like as much
formalized
as
standardization.
Got to work with the kernel, so that's what matters. Huh?
Yeah. I mean, it's an established practice of collaboration, right? I mean, it's the most collaborative software project in the world. Most collaborative project in human existence.
Unless you're dealing with Linus, and then and then he's just angry.
But the Linux community as a
just
whole
a joke.
is
just let
angry.
That one go. Let's just let that one go.
All software developers in all walks of life are angry and
grumpy in some way or another. I know. Hey man, I'm an analog engineer. I've seen my share of grump. So.
Yeah, but he hasn't yelled at the ARM group for us in like 6 or 7 years now, so we're good.
You're due, man.
The ARM people are good.
Got it. Okay, so I wanted to talk about the other stuff that's on there, because this is the piece that I've been probably waiting 50 minutes to get into it, but I feel like this is the thing that I know Jason talks about a lot, but I don't think it hasn't been highlighted on here enough. Mostly because I don't know how to do anything with it. But there's the PRUs on there. So what are the PRUs?
Is that my cue?
Yeah.
So they're
evangelize, Jason. Evangelize.
They're 32-bit RISC cores that are optimized for low latency. They're zero depth pipeline, so even something like a Cortex M3 has a 3D pipeline. So they're ideally suited for creating software implementations of peripherals. So PRU stands for Programmable Real-Time Unit. And there's a whole subsystem around there. It's called the PRU ICSS, or Industrial Control Subsystem. So
that sounds friendly.
Yeah, isn't it? Gotta love those TI acronyms.
Yeah.
don't get me started on TI 15.4, but
Whatever.
yeah. Anyway, but it's an amazing little subsystem that can implement all sorts of industrial protocols, including such mundane protocols as RS-232s or UARTs, right?
Right.
But
So that's the idea. It's like it's spinning out there like a little widget that's just doing its thing, waiting for commands. You're not saying go poll this thing. It's just sitting there and doing the polling for you or doing the outputting for you or whatever. Right?
Exactly.
Yeah.
Some IO pins are actually register mapped, not even memory mapped, but actually like in I'm assuming I can talk like R30 and R31, that at that level of people's understanding of microcontrollers. But so one of the registers is actually directly mapped to the outputs, and another one is directly mapped to the inputs. And so you can do XORing on a pin, and you could actually do there's zero overhead loops. So you could do read XOR write on registers in a zero overhead loop at 200 megahertz.
So it's like having having a logic gate pretty much right there, but it's all program. It's almost programmable logic, right?
Yeah. I mean, if what you want is a collection of XORs, or for some reason, yeah, you could run a 200 megahertz XOR, right? So 10 nanoseconds. From input to output, it's under 10 nanoseconds. It should be something probably more practically like 6 or 7 nanoseconds.
That's pretty crazy. So and like you're saying, like so for the real time piece of like making it so like reacting to system inputs or anything like that, it's just right there. It's already doing what you need it to do.
Yep. And you can just memory map them into the processor space. So the ARM processor can directly see the internal memory of the PRUs, and the PRUs can write into the it's called L3, but like the on-chip peripherals as well as the things like the DDR, right? So the PRUs can actually write to the DDR, and they can just
for doing like a DMA type of thing.
Exactly. If you just if you want to do a pure software DMA, which is if you've heard of the Beagle Logic project, it's a project that makes a 14-channel 100 megasample per second logic analyzer. It just using the PRUs to do a soft DMA.
That's cool. Yeah, that's great. And then like it uses SIGROC to actually analyze it, right?
It does. Yeah.
Yeah.
So nice
cool.
little
Is that
nice little system.
Kumar Abhishek doing that?
That's the one.
Yeah, that's cool. No, it's a cool project. I remember seeing that. So,
but it's a nice example of just how fast the PRUs are. Just doing it in software. You could do the same thing with like a DMA, but it's just interesting.
Right, more flexible, more recompilable.
Yeah.
So, and that gets to my question about it. So, how does one actually do this? Because I remember looking at it at one point and seeing something about Code Composer Studio and going, nope, and going the other way. Is that proper?
We shipped a C compiler on the boards actually in Robert's images.
Okay. So maybe I'm getting this. Maybe I got that wrong then. So
no, at one point that's what it was. We kind of had to show the kind of legacy of this is TI was. I always say TI like a third person, like I don't work there, but it kind of the
it's like an older brother that beats you up sometimes.
the approach was okay. The PRU is something we're going to use for supporting these industrial protocols, and we'll provide firmware, and we're the only ones that can program it. And oh my gosh, this is just way too complicated for the real world, and for the other people. And so the coup I got was. We took the chapter that was originally written for the technical reference manual that had been removed after being kind of reviewed by managers and saying, okay, this is going to be too much technical support. We don't want to have it out there.
That's fair. That's fair.
Yeah, and published it separately, from on a BeagleBoard GitHub that this is the base technical information, and don't call TI.
Here's a forum. Don't go other than the forum.
Yeah, exactly.
Or mailing list, probably, right? Yeah.
And it's this doesn't really exist. If you come and ask questions, we're gonna say that. Anyway, what happened was the community loved it. They started making all sorts of cool things out of it, and it started. I think a lot of it started with some of the folks doing 3D printers. Some of the cool MakerBot guys, back when MakerBot was cool.
No comment.
And they started doing stuff with it. Trammell Hudson did some really cool.
Trammel's great, yeah.
Some really cool lighting stuff. He's anyway. People started writing cool code for it, and eventually the powers that be said, you know what, this seems to be working out pretty well, and so now it's an officially supported peripheral inside the processor.
So you said, Robert, you have this in your build now. So what does that actually mean?
We actually support 2 versions of it.
Okay.
Because one of the problems was it became so successful with the old 3.8 kernel images that we still have to support the old way people were accessing.
Oh no, do you have like a Python 2 versus Python 3 thing, or what?
Yeah, more like a Python 1 versus Python 6.
Okay.
Completely rewritten
okay.
4 times.
Okay. Oh my god, really? Okay. So
yeah,
so the 2 versions are 3.8 and something else?
Yeah, 3.8 is the one that was the most used by almost everyone. Uh-huh. There was a version in 3.14 that was slightly different, then 4.1 was even differenter, 4.4 was different again, and 4.9 they changed things. Okay. So yeah.
Which of the 2? So if someone was going to start today, which should they use? I mean, that's a better example.
If you have a project that is based off something else that someone has already done a huge library for, use the old 3.8 version.
Okay.
And we support that through all the kernels. If it's something newer that there's some projects exist or Jason's ported it, use the new version.
It's not that hard to move the code. There's the 2 different drivers that people really talk about are so we're not talking about the C compilers, but the drivers that people use to talk between the processors. One's called UIO and the other one's called remote proc. And I think that, Robert, I may be speaking about the wrong thing, but I think that that's one of the biggest differences they see between the older and the newer interfaces is which driver they're using. The newer one, actually, the kernel loads the firmware rather than your like a user space application loading the firmware on the PRUs. And that's the only hard requirement. A lot of people think of a lot of other features that are in the newer driver to message between the 2 and do some what they call remote proc messaging or RP message, and that requires a little bit of firmware on the PRU itself and kind of some understanding. But you can just use the new loader and then memory map the PRU and use it all the same way you're using it before. Just dump into some shared memory location. But most people don't understand that you can still do that, and so they make the problem harder than it really is.
So 3.8 is referring to the kernel number, is that right?
Yeah,
correct.
So
yeah, it's still there.
So what? I don't get how that can work then. So I guess this kind of goes back to that early conversation. Like, so you said that it's currently on 4.14 now, 15 today, but what? So how does it still work with the 3.8? I don't get it.
Oh, we still support 3.8.
And people will still do stuff with old code.
But what does that actually like? So what does that actually mean though? Like, so does that mean that they have foregone all updates, or is it like all of the new stuff got backported to the old stuff?
So one of the things we do in the repo is we allow you to choose basically any kernel that you want, and we almost never remove it.
Oh, there's a problem.
Well, on one side,
there's your problem.
Can have it. Yeah. Well, we want to make sure our users, if they have something built, and then, Jesse goes into life, so they have to move to Stretch, they could move to a different OS and still have the same kernel.
See, okay, this has always been confusing to me, stuff too. So now you're talking about distributions too, right? So so I'm on Stretch currently. Stretch is the newest Debian for stuff, right?
It's the newest stable.
Yeah, and on a Raspberry Pi, I remember it gave me a whole crap load of issues with Wi-Fi. I know that. But so I switched back to Jesse, but that has nothing to do with the kernel, though. You're saying that that's completely detached from the kernel.
It's completely detached.
And
so you can run Jesse, Wheezy, Stretch, or SID all on the 3.8 kernel.
Why?
So that way,
why is this possible? So what? I guess maybe a better question though is what breaks? What breaks when you don't? So when you go from 3.8 to 4.9, what actually is it? Just like all the interfaces have changed, or the memory locations, or what?
A lot of things in 3.8 end up going mainline, but at the same time, lots of things changed on mainline.
Okay, maybe I need to have main line needs to
what
be
breaks is
like,
very
defined too.
Is very specific to what you're trying to do. I mean, I always try to tell people do anything you can to stay on the latest, and just run.
I feel like I
with the
should be
community.
like channeling Dave right now. I mean, like right now, Dave would be like, "Why? This is why I only use Windows," and that's my worst Australian accent ever, which is a load of crap too, right? Because they obviously deal with this stuff too, but it's just it's hidden from all of us. But like, damn, there's a lot of stuff, guys. I mean, like.
Yeah. Well, then a lot of times too is someone will build a project based off something, and they wrote all the kernel interfaces, all the tweaks, they got it working, and then 3 years later they need to upgrade the OS, but they have everything tied to the one kernel. So now they can easily seamlessly upgrade the OS and still boot their old kernel with all the interfaces, and they keep on buying our board.
And that's a good thing. That's not a bad. I thought you were going into a bad thing there.
Yeah, it's a great thing.
So it's a good thing.
So while it's complex that we have so many kernels available, it allows end companies and end users to have a more stable kernel. That it'll always be there. We don't have to worry about changing kernels if we don't want to.
So if you wanted to keep the same kernel, right? So let's say 3.8 is just the best kernel ever, and you want to keep that. Why are people updating the distros then? What do you get that's not in the kernel?
Well, they want the latest VLC media player. They want OpenSSH patches. They want
I guess Heartbleed is kind of a thing. Huh?
Upgrades. Yeah.
Yeah. Okay. So security would be a big one, but UI and UX and all that crap too, right?
They want to run Python 3.
Whoa, let's take her easy there. Yeah. The world's gonna break at some point just because of the rift, and I've only learned about it lately. I don't have a dog in the race. Okay, so that's really interesting. So, what would then lead someone to go from? So now this person's on 3.8. They love 3.8. They've updated through all these different distributions over time. They get all these pretty updates on the other side of things. What would make them change? Is it just a hardware change?
The biggest change is if they want to run the Pocket Beagle or the new blue or the black wireless or the green wireless, they need to run a newer kernel for the newer interfaces, like wireless.
Oh,
we didn't backport support for the wireless chip into 3.8.
Okay,
it's like,
and what
3.8 will support what it did. We'll keep supporting it, but we're not going to backport newer stuff to it.
Right, just because of the overhead and headache of doing all that. Right?
Yeah, if you want to do something like mesh networking, I think you need at least 4.9 to do the 802.11s mesh networking with the BeagleBone Blue.
So it feels like the kernel stuff you're talking about. If you want new hardware support, you have to update the kernel. If you want new software support, you have to update the distro. Is that fair?
That's a good generalization of it. Okay. Yeah, because the way Debian works is that they'll stabilize everything together so that it works as one unified package, and then lock it down. And then 2 years later, you get all the updates, and you do it again.
Right. Yes, I also have servers, and I've seen that.
Yep. Yeah, it's stable for a reason. Nothing changes.
Long-term support is the name of the game for me. Yeah, 5 years, 5-year packages.
But newer software systems like ROS, like these different framework packages and stuff for your newer versions of Node.js, Python. Some of these things you start getting libraries that get too old, or other systems that get too old, and you kind of have to make the leap to the next.
Right.
Distro version.
All right, so we got a little bit away from it, but let's go back to the PRU real quick. So now on the device, there is a compiler that allows me to write code for a PRU. Is that correct?
Correct.
How do I do that?
It's just C.
So it's like, but I'm saying, is it like a makefile, and like, is it like that style of things?
A gist that I always point people to. If you go to beagleboard.org/PRU and ignore all the old stuff in the beginning, go all the way down to the bottom. I mean, the old stuff is interesting and informative, which is why it's still kind of first. But if you scroll all the way down to the bottom, there's a single set, like it's got a makefile with way too much in it that you don't need, but it's got a linker command file with way too much stuff in it that you don't need, and it's got essentially a hello world application, which is toggling some GPIOs. One's through the on-chip peripheral bus, and one's through the I/O pins directly on the PRUs. To me, that's a
Okay.
good place to get started, right?
No, well, yes, and no. I mean, so again, I'm going to be honest here, guys. I usually don't compile with make files. Like, I'll do it if I got every command in front of me and someone's written the code already, and I'll just need to hit make. But I don't do that really. So that's what I'm saying is like that's where I start to fumble. So I guess I need another pointer towards another
You need to
thing that
you
shows me
need
how
to
to do that stuff.
specify a linker command file because the peer use you don't load with like a relocatable relocatable binary, which is what you so you need to actually give it a memory map that says, okay, these things hard load here into memory. And other than that, you're pretty much just compiling it normally. So we could strip out and give you the single command line. That's but you still need a linker command file.
Well, I'm not saying that I'm not capable of. I can follow directions. I'm just saying that that's for someone like me. That's it's a little outside my wheelhouse, or at least comfort level, right? I mean, and I've been doing this a long time. I've been uncomfortable. I've done FPGA stuff. I've been uncomfortable. So I guess that's what I'm really saying though. So that's good to know though. So to get to the point where you want to use a PRU, you're going to be doing make files and all that stuff. And,
you don't have to
build
do make
scripts.
files. I will give you the single command line. The only thing that's kind of magic there is you need to specify a linker command file. Other than that, it's the same old stuff. You point to the include directory.
So maybe I should step back even further. My experience is like IDEs.
Oh,
so like that's where I'm coming from. It's like IDE world, right? So it's like it's not that, and that's fine, right? It's fine. It's not. But I'm just saying that like there's nothing out there that's like, well, this isn't an IDE. You're not going to have an IDE. Do you see the disconnect?
It's ultimately it's a little hard to use Beagle without getting a little bit comfortable with the Linux command line.
I agree with that. And I think that's probably a good thing to do. Maybe someone needs to make a video course, and maybe Chris will.
Well, we're about to make a whole video series.
Perfect.
So I say we. I actually mean Beyond Webster and a group of people. There's a website called e-ale.org, and he's putting together a video series of training on getting started with Linux, including making some some I2C and SPI drivers, and there's a whole series of really nice experts.
Well, I can say definitively that stodgy old programs that have improved quite a bit. Having a video course can help a lot. So, KiCad, that's a KiCad reference. But it does. I mean, it does help. Like, so just again, I think about it so much too. Is like it's like a momentum based thing, right? So it's like I am. From a momentum case, I am more than comfortable at least opening up an IDE and being like, oh, okay, I've seen this kind of thing before. I can probably do this. But I see like the whole command line thing, and I'm like, maybe not. Okay, cool. So you follow these directions. You follow this gist for doing the coding, stuff like that. I guess, is it like just once you compile it, is it just up and running immediately?
So you need to tell the kernel to load it. So you put the executables inside of lib firmware, and you tell the kernel to load them, and then it's running. And then when the kernel boots each time, it'll reload that firmware again and have it running.
Right. And so this is and this is meant as it's like a whirling dervish that's just running code, reading, writing, doing whatever it needs to do. That's kind of what it's out there for. It's just
totally
sitting there in a loop.
Independent from the main processor.
Yeah. So to actually get this in there, then, so there's a compiler. So there's a compiler sitting within the kernel then as well that's also ready to do all this stuff. Like how does that all work?
So there's a compiler in user space from TI that we ship, and that'll build a binary blob that the firmware loader will load into the PRU directly, and it'll just basically run.
Okay.
So it's all. The user space compiler will build it into a binary that just runs on the PRU.
Huh. There's more than one, is that right?
Yep, on this one there is 2.
Okay. And
I always got to think what chip it is because
this is
the AM4 has 4 PRUs and the AM5 has 4 again. So
okay. And so this is, and we're saying this one, we're talking about the Pocket Beagle in this case.
Yeah, on the Pocket Beagle. So
okay.
So you have 2 PRUs to work with, so you can have 2 different binaries load, and they just run independently.
And so like when people are writing, so are there actual hardware drivers within there as well, or is it just kind of like bit banging? So like I think about it, one of the benefits of using a microcontroller is, or like a hard peripheral on a microcontroller, is it kind of handles all that stuff that's out there, right? So there's a SPI port, you write into a register, it shifts out those data, the data from that. Is this kind of taking that and saying, well, now you write the software to do the bit banging? Is that the idea?
Exactly. You're writing the software to do your interfaces, to do your algorithms, to do what you need it to do.
Okay.
And so it's a general purpose.
Right. So you lose some of the hands-offness of it, of a normal microcontroller, but you get the speed and whatever else you need to do.
Yeah. It's like you lose the specialization.
Right. But
So
you
you
can
can-
gain the flexibility, right?
Exactly.
Yeah. Okay.
And that's where you can see so many unique things that people have done with it.
Well, so what are some of those things?
Like the big ones with the 3D printer guys when they're doing all the movement controls.
Oh, okay. So they're using like one of the four PRU setups and doing like stepper controls.
Exactly.
Oh, wow.
And they got it tuned to what every instruction takes for how long, so they know exactly how fast it is to move.
Yeah. Yeah, I remember I had a former coworker who was driving a huge ass what are they called, NeoPixel display, and those have pretty finicky timing. And I remember he liked using the PRUs for being able to shift out just the right precise timing on each blip you needed to get to each individual pixel, and that was like a very good case of that too.
Yeah, but then on Ken Sheriff's blog, he had an awesome case where he's using the PRU for that old computer for a network interface.
Oh, that's right. Yeah. Okay. Network interface. That's crazy.
It's like some archaic. There was, no one has this network controller again, and he got it working.
Yeah, that's great. So, so it sounds like, okay, so we were talking a little bit about the build process. Is it starting to move towards, so is it just that's all you get, or is it trying, did I remember you said something like there's going to be an interface on the Linux side that allows you to write the code there?
So for the PRU, it's mostly about take an existing example, tweak it for what you need. There's most of the time it's just a make file that you'd have to call to do it.
Okay.
And I'm pretty sure in ops source on our default images, we have a PRU software package folder.
Uh-huh.
And I think a lot of the examples are in there.
Oh, okay.
It's been a while since I looked at those, and then otherwise we have our Cloud9 IDE interface through the web browser that you can also access them through that.
And
so
what is Cloud9?
Cloud9 is just a web-based IDE that's now owned by Amazon. It just allows you to point and click and create files in a traditional IDE type environment, but through your web browser.
Oh, so I would be able to do that. So I could write code for the PRU in that thing now?
Yep.
Oh, okay.
You can create text files. It supports multiple languages.
Okay.
I don't think there's a semantic viewer for the PRU exactly, but like for C and Python, it'll show you interesting things as you type.
Oh, got it. Like just like the keyword highlighting, stuff like that.
Exactly.
Okay.
Function highlighting it.
That's great. No, that's actually really great. Okay. And I remember you said that there was going to be other like kind of that GUIification of stuff, right? Because that seems like what that kind of is, like the Cloud9 idea.
So for the next generation, we have the Cloud Code Red project integrated into the system now too.
And what is that?
It has it's basically like your Lego blocks where you can move modules around, connect them up, where each module does something different, such as picking a web server, opening a file.
Okay. And so just
nice
kind of like
drag and drop interface.
Yeah, like wiring it together kind of. And
exactly.
Well, that's friendly. Can you do like actual interesting things with that, or is it more just kind of simplicity for getting things started?
We just integrated a package for talking to the I/O directly, so you can move pins up and down, pull downs. You can talk to serial ports, CAN interfaces, Ethernet ports, ADCs. So
this is kind of building on that the Linux kernel kind of access side of things. Is that right?
Exactly, and it's going through Node.js, so there's a lot of power in there.
What is it doing? Sorry, I don't quite understand. Like, so it's using Node to like write to the kernel. Is that right?
It's using Node.js to make the GUI, and it's basically just running JavaScript behind the scene.
Okay. So, I see. So there's a graphical element that then is paired with some kind of JavaScript, which then is What?
right into your through your browser.
So it's, okay.
Yeah.
Okay. And then
Node.js is very powerful and on servers and embedded systems, allows you to do a lot of fun things.
yeah, so I've heard about. I mean, I've done a little bit of stuff with it before, like at least used other people's code at least, and I know that like it's server and client. That's the thing I always hear. But like, so it's I get that like you have the duopoly of like two things talking to each other, but like then on the server side, it must be talking down to the hardware, right?
Yep.
So
it has hardware abstractions in there for different devices.
Okay.
For I/O and
so the same thing of just like it got compiled for whatever system it's on as well, and
yeah, it got compiled native for what it's run on, but otherwise it's just running JavaScript on the outside.
okay, well that's pretty cool. I mean, not that I can write JavaScript either, but like it's nice that it's accessible. So that's
Yeah.
cool. Yeah, that's great. So, what? I'm sorry, I'm a little thrown off now.
Back to the PRUs.
Yeah, back to the PRUs.
Back to the makefiles.
Right. Well, yeah, I guess so.
And a lot of times, for a lot of them, like the Machine Kit guys, they had a PRU library they kind of built and set up so that anyone that wanted to make a 3D printer, they just ran the binary and sent the right commands to it, and they never actually had to rebuild the PRU binary.
So the PRU, I mean, like more and more, this sounds to me like a logic element, right? Like you make
Essentially,
yeah, you make the thing once, and then you just kind of use the interface to it. You don't do anything else.
Exactly.
Interesting.
And for them, it was basically they created a stepper element.
And then they would send like an API, like it acts like an API, and you say move to position XYZ, and it just does it, or I guess
Yep, they just gave it incremental, like move this, move this, and yeah, they had a big what they call their hardware extraction layer where they separate the PRU from the hardware. That way, they port to other boards and like.
Oh, that's a good idea, right?
And they also relied on the real-time kernel to take advantage of a lot of the accuracy of
yeah, like the super micro stepping stuff and all that stuff they do, right?
Yeah, because you want to have when you have a laser printer, you pretty much want to make sure it gets to where it's supposed to go when it's supposed to go.
Well, only if you want it to look like you want to print,
Yeah. But of course, some of the machines these guys are working, like plasma torch, and you want it to go where it's supposed to go when it's going.
Right. Only if you want fingers.
Yeah. Or if you don't want a hole in your wall.
Right. Exactly.
Stay here too long with the torch.
Right. So okay, so as I may have mentioned on the show, and I think you and I have emailed about too, and Jason as well, who had to drop off here for a second. I am actually working on a cape now, right? So whatever we're calling pocket capes, is that the right term? Yeah.
I'll let you know tomorrow.
Okay.
It changes weekly.
Oh, okay.
Because we've already had them as BeagleBone capes, and then before that they were,
Okay, so tiny board that plugs into other tiny board. Okay, so if I was going to interface with that thing then, right? Because I'm only at the layer where it's just now starting to talk. So I'm talking to the serial port on that thing. I'm just going to have you troubleshoot my problem live on the radio here, on the podcast.
Sure,
here.
sounds good.
Great. Okay, so...
Make sure the ground's connected in the serial.
Yes, thank you.
The RX and TX won't transmit if there's no ground linking them.
Right. Well, this is actually going to plug right on, so all the grounds are hooked up. I guarantee that.
Oh, then you're set. You won't have to worry about that.
Exactly. Well, RX and TX being backwards, I mean, then you got to do that once. I think the only reason this is actually going to work is because I actually swapped RX and TX twice on the board by accident. So
So you have two jumpers set up to reverse them every time
much,
now.
Yeah. You know how it goes. It's a prototype.
Yeah.
So I'm going to write to the serial port 4, I think, on the Pocket Beagle. So I'm going to write to that. So I should just do that with Python then, or should I take that down into the PRU, or what should I do there?
Whatever language you want to. By default, most of the UARTs are set up. Let's see, on UART 4, I gotta find the schematic again.
Okay.
So if in our table that we created that ship with every board, if it says UART out of the box, it will be a UART. If it's not a UART or SPI or something else, you have to use the config pin tool to change that peripheral to a UART.
Config pin tool. Okay, that's good.
So we have a tool that's in user space. It's called config pin. It allows you to change the pin mux of every pin on the Pocket Beagle.
Really? Oh, I didn't actually know about that. That's good to know.
Yeah, because one of the limitations of kernel drivers is that when you enable a peripheral and set it up for a pin, it's locked in that mode.
Yeah. Okay.
And so we have our own big patch that kind of undoes that, where we have a default mode, and then, say you want to change to something else, we allow you to do that.
And you're not saying any pin. You're saying like the predefined pins of where you see the pin outs, and there's like 8 or 9 functions per pin, right?
Yeah, exactly.
Okay, so it's not like a crosshatch
out
where you can make any pin into anything else. It's
we're not moving pins around.
Okay.
Each pin has about 8 functions, and we allow you to individually change them.
Okay, that's great. No, that's actually really useful. So
that's one of the questions a lot of people end up around. It's like, I want to use this UART. So the first thing is make sure it's actually in UART mode.
Aha. Okay.
And then once it's in UART mode, just talk to it through dev TTY. In your case, UART 4 would be O4 or S4.
Huh. Okay.
And this talk to us through Python through the UART library.
Okay, that sounds pretty simple then. What a great test case. I will just send you my code and you can help me troubleshoot it. Great. Awesome. Okay.
And one of the crazy things you could actually do with this config pin library is you could actually hook up a UART and I2C or SPI to the same pin.
Uh-huh.
Put a UART mode, talk to the UART device, put it back to SPI mode, talk to the SPI device.
Really? That sounds like a bad idea, doesn't it?
That was it's a bad idea.
Yeah.
But that's kind of the idea that went, let's try this and do this.
Yeah, and it works.
So that's the way it's wired.
I mean, I guess it's just if you send like a serial command to an I2C, you're not going to have as many pins. Well, you might have as many pins, but it's just going to look like garbage, right? So
yes, look like garbage.
Yeah. So that's the idea is as long as
and
your
normally
part
no
doesn't
one would ever
care.
do that.
Right. Yeah, as long as your part doesn't have a self-destruct mode when it sees like bad data, you're probably okay, right?
Yeah. And so that's the way the config pin was written. It's like, well, all the peripherals are enabled, and we have control of all the pin functions at the end. So leave them enabled and just change it on the fly.
That sounds kind of yeah. I mean, I feel like a million monkeys on a million typewriters kind of problem. Like if you send the right bit patterns enough times, you might put it in a bad state. Like yeah. But okay, but you could.
But for new users, it's kind of nice because they don't have to recompile the device tree or configuration or change anything. They just log into the user space. Oh, a config pin. I want to pull up here.
That is actually pretty nice. Okay, cool. I also assume that would be a big headache, but
yeah, it's a huge headache.
Right. Okay, but is there a way to visualize what it's actually set as right now? Is it just like you can go do a display of what's actually set to what?
Yeah, config pin has like a list and a query. You can do a list for all the options for every pin.
Okay.
And it has a queue which for query tells you what mode it's in.
Okay.
One of the problems is when it's in the default mode, it'll actually say default, and then you have to look at the device tree. Oh, default for this pin meant UART.
Got it. Okay. Well, you can look at the pin out the main pin diagram, right? That's like the default.
Yeah. So it's not 99% useful. It'll get you mostly there, but
I mean, if I've got, RX and TX going to the right pins on the right part of the processor, I'm usually doing pretty good. So
yeah.
Okay.
So just make sure they're in the right mode, and then basically use any UART library.
Any UART library.
Yep. Whether it's Python or Node.js or C.
Okay. So I guess I'm still stuck on this piece. So if I was going to write... So I get the Python piece now, right? So that's running basically a script on the device, right? It's just going and it's basically doing what you're talking about. It's like writing to a file or, pulling from a file or, manipulating strings in memory or whatever, right? That's what I get.
You're just opening a file and then you're just sending data to it and pulling data from it.
Yeah, that makes sense to me. I finally got my head around that with the moving into the Python world. That's great. The thing so you're saying writing C though. So if I was going to write C for this, then what? I do the same thing where I compile it down and put it in the right memory space, or I guess that's the piece I don't understand. Because because my flow has always been like an IDE where it gets, a executable at the end, you go and load that on your part, and then it's got, stuff to do things,
Yep. Well, in C, you're basically going to F open the file because it's still a folder in a file.
Right.
And so in C, you're going to open it up, set up the right IO values for control registers.
But again, I guess the piece I don't understand is where is that? I mean, I know that this is happening for the other languages behind the scenes. So
it's behind the scenes in Linux.
Right.
And so the Linux driver and the kernel is taking care of all the low level stuff. And so it has a unified API that everyone else just using to talk to the UART.
Right. But so now the user code, if I'm writing the user code in C and it's getting compiled down, where is that going?
Yeah, it's just using the regular library. And then
It's using the regular library.
Yeah, it's just basically running on target as is, like a regular application.
Huh.
It doesn't need to know what processor you're on or what architecture.
That's crazy.
It's just generic C for talking to a serial port in Linux. And so if you have it working on an x86 desktop, that same application will work rebuilt on ARM.
See, I think what this all brings to a point for me is just how little I understand computers. Like, like the full-blown computer thing. Like, I'm getting more comfortable over time with microcontrollers, but damn, there's just so much going on with computers.
Yep. There's so many abstractions going on, and it hides all the hard stuff from you.
Right. I think I'd rather see the hard stuff at a certain point, It's like, I'd just rather get in there and, peek and poke at some registers and...
And we tell people you can do that if you want, but it's hard to maintain and hard to move forward.
Right.
I mean, you can make an application that it's poking on a bunch of stuff, but then a couple years down the road, how do you move it to the new OS or the new changes?
Right. Well,
you're stuck.
And I think the other thing that we were talking about before too is the portability and the distributed nature of it all. Right. So like, I might be able to get it to work, but it doesn't mean if I send you the code, you'd be able to get it to work because we might be on different systems. We might have different stuff going on, whatever. Like that's the piece I think where that's the real power that comes in. Obviously there's it's never going to be purely it's not going to work on everything, but it's going to work on some things or it's going to be close enough. It's going to work
on most.
Yeah, right, that's really cool. And you don't hear about that much. I don't hear about that much, at least. You hear about like modularity and all this stuff, and like, wouldn't it be great if everything works together? But it's kind of already there, sort of,
Mm-hmm.
So, yeah, that's great.
and of course, the way Linux usually works too is if a serial program that was built like 10 years ago worked, you can rebuild it today, and usually it'll work again too.
Right. That is actually really, that is true. I think that people underestimate that piece of it.
Yeah, that's one of the big goals of Linus was that we're not going to break user space applications. It might be a bad API at one point, but we'll change all the kernel code all the time, but we're not going to break people's applications on the end.
And has that delivered or no?
It's pretty much delivered.
Okay, that's good. Like I said, Jason unfortunately had to drop off, but I did have some questions about like just the future. Like what is the future of the project? I you're a board member, this stuff too. Like where is this all going?
I think we're just going to keep on getting smaller and smaller devices that are getting more and more powerful.
Really? Okay.
If you look at where we've headed, the original Beagle was a 600 megahertz chip, then yay big, and
that's good. I mean, I think cheaper helps too. I mean, like obviously having like, so I've talked to people, like I said, in the industrial space. I think that making Linux more available in terms of just the UI, and people just expect UI these days. But
yeah, you got to remember Linux is just the kernel. It's not the GUI.
Right. But
so
it enables more people to develop code and UI elements for it, right?
Yeah, because there'll always be something else on top to show the GUI, whether that's Wayland, whether that's X, or whether the next generation, whatever comes out.
I don't know any of those things, but I guess is it like Qt and WX and stuff like that too? Yeah. Or is that what X is? I guess X Windows, yeah.
Yeah, X is your standard X Windows. Okay. Wayland is what everyone's thinking that will replace X someday.
Got it. Okay.
But a lot of the times, for a lot of our embedded systems, we don't actually have a display to work with.
Oh, really? Okay.
It's like on the Pocket Beagle, you want to have a display on there, you'll have to connect a SPI or an I2C. That's where having like a display like an embedded web server makes more sense with Node.js. Because you don't have a GUI on the Pocket Beagle, but yet you can log into it on the web server and create your own GUI through the browser.
Right. And that's actually how, that took me a while. So I was following Ken's tutorial, and at first I was like, where the hell so like you plug it in, it shows up as a network device, like through USB, which is cool. It shows up like an Ethernet port, like a virtual Ethernet port. That's cool. And I was like, now what? What do I do? And it was like, oh yeah, it's like a web page. Okay, that makes sense. And
you just log into it, and then magically, wait, where does ID come from?
Right.
It's like it was in there the whole time hiding.
Right, exactly. It's like a whole package of stuff. So actually, that's a good segue too. So if I wanted, so I think one of the things I was struggling with, and I think Ken mentions this in his tutorial too, is like, so there's no Wi-Fi, there's no connectivity on it at all, actually, on the Pocket Beagle specifically. So doing updates and stuff like that is a little problematic.
So yeah, on the Pocket Beagle, there is no Ethernet port by default. There's no Wi-Fi by default. There's nothing to get out of it by default.
Right. Absolute low cost. Right.
Yeah. So what we have set up is it's an Ethernet gadget, and it was kind of intended where you'd plug it in and then you can talk point to point. And the problems exist is what OS are you running, and how do you have your network set up?
Okay.
And there's some things we can't detect. We can't say, oh, you're running Mac, do this option. You're running Windows, do this option. Or running Linux, do this option. And so there's a little bit of setup that everyone has to do based on their systems. I know for Windows and ICS, all you have to do, if you use the serial port instead of the Ethernet port, if you just type DH client and then USB 0, it should connect in and your ICS will work. On Linux, you just have to do sroute. And then I still haven't plugged it into my Mac, so I can't tell you how to do that one. But Jason could.
Okay. All right. So the idea is but it's just sharing. So on a host computer, I'm sharing the network.
Exactly.
Okay,
You're just sharing the network, and then you got to forward the gateway. Usually, we just throw 888 for Google's DNS, and then things magically start working.
Okay, well, that's good. Yeah, I mean, I guess the main thing that I think about is that usually anytime I get a new distro, I mean, I know that this is not necessarily the case if I'm downloading the latest image and burning it to an SD and putting it in the thing, but like in the normal case, I would think it's like I want to go and update and get all the security patches and whatever I want to do, right?
Yeah, and one of the things we do is all our images do that by default. When you plug it in, you'll have 3 USB drives show up. You'll have a USB flash, which used to have the drivers for Windows before we figured out a way around that. It has some documentation and some links. It has a USB serial port, so you can log in as a serial, and then the USB Ethernet.
And that's all through the same micro USB.
Yep, all through the same micro. And we've kept that going for like 5 or 6 years. That's been the default. Those 3 interfaces will always show up.
That's great. And then how much of the file system is actually visible via the USB flash?
See, the USB flash is actually it's actually a fake image.
Okay.
There's actually an image file on the drive that we point to it, so you're actually looking at like a 32 megabyte image file.
Is it just like a transfer area, or what is it for? Or is it just for the?
It was just for documentations and for Windows drivers back when we needed Windows drivers.
Oh, I get it. Okay.
Yeah, we had one of our buddies that's done a lot for the organization, David. He figured out a couple magic strings that we could shove into the USB driver. Then Windows would, hey, this is registered.
Oh, nice. Okay.
You don't have to have a key and a license to hack for a Windows driver. So
hacking.
We've since moved to that, and he pushed it all mainline. Here's the magic code you need for this driver for Windows to detect an RDNS driver.
Nice. Okay.
Sadly, it doesn't work on Mac.
I'm finding that I've been through some struggles lately, so yeah, I know how that goes.
But so if you plug in the Pocket Beagle to Linux OS, you're like, why is there 2 Ethernet ports? Well, turns out Mac recognizes one, Windows recognizes the other.
Oh, really? Okay. All right.
So Linux people get both.
Okay. So the idea though is, so there's that Ethernet, and basically I just have to tie my Ethernet to my host Ethernet to that device Ethernet.
Yeah. And the way we have it set up is the Pocket Beagle is actually a DHCP client. So when you plug it in, it'll tell the other PC and give it an IP address. So the IP should, in like 95% of the cases, come up. And then you should be able to at least IP talk to each other. Then it's mostly just talking about change the routing and set up the gateway.
Cool.
But yeah, that would be a nice project if we could figure out, hey, we have a Windows, ICS is enabled. Do this by default.
Were you saying, what is ICS? Sorry.
Internet connection sharing.
Okay.
So in the Windows world, it's how they do it to share internet.
Okay.
So it'd be a nice project if someone could figure out, hey, figure a way to detect that by just plugging the USB port in.
Yeah. Yeah, that would be really nice. Yeah. If it's just, I mean, that's the thing. Like the magic of it just works is really nice.
Yeah. And it's really hard.
It's really hard. Yeah, exactly. Yeah. So one thing that I've realized is that I value time more than money these days. And one thing, so I was going through this whole thing with the HackRF, which is a great little device, but like it was a shit show to get it set up, to be honest. I mean, like I love it and I got it finally, but it was a shit show. And it was because I was just not doing what most people do, right? Most people are like, well, I've got a Linux box, let's plug it into that, right? I don't have that. I'm traveling with a Mac for work, and that's all I got, so I had to struggle with that. If someone was gonna, best case scenario for them, what should they plug it into? Should they have a Linux box?
For this board, right now set up any of the 3 is fine.
But give me a best case. I mean, I agree that like usually that is the case, but like there's always a best case.
Yeah. To get if you just want a network set up where you can talk to point, the Linux is about the easiest right now.
Okay.
For getting it to the internet, if you already have Windows ICS enabled, it's only one command you have to do on the Pocket Beagle to get it connected.
Okay.
Whereas on Linux, it's like 2 commands. That's what we're down to.
Okay,
it's like, how much do you really want to type?
Yeah, well, sounds like I'm going to be doing it either way. So, okay, that's good to know, though. And I think, that's the other thing that's amazing about this price point too. Now, again, this is within the realm of the Pi Zero and the Raspberry Pi and stuff like that too. But for the BeagleBone project, BeagleBoard project, right? This is the lowest price one yet. And so if people want to try this stuff out, and like I said, if you want to be able to put the damn chip anywhere else, you're just not going to do that with a Raspberry Pi. Even, you might be able to buy a module or a memory or whatever they call those things, the compute modules. That's fine. But I'm saying if you want to put a chip on a board, this is the way forward, I think.
Yep, and build your project around it.
Yeah, exactly.
And we've done it before where people have made small changes and, here's the 10-line kernel patch I need. Like, oh, I'll take it. And we just put it out in our default distro so their stuff is supported out of the box.
Yep. That's great. That's really great. Yeah, so I think that this whole Pocket Beagle, the reason I'm so excited about it because it's redesignable easily, it's cheap, and I think that getting started is, it's a little bit bumpy still, but I think it's, this thing only came out like 3 or 4 months ago.
Yep.
Yeah. So.
And it's kind of amazing to see all the new Pocket Beagles that have come out as far as so they've taken the design, tweaked it here.
Uh-huh.
It's with the easier layout tools of Eagle and KiCad, people have made derivatives a lot easier.
Yeah. Yeah. I made a little cape thingy to plug in board, whatever. Even just grabbing the header, there's no way you can be wrong. Well, you could be wrong, but it's hard. It's a lot harder to be wrong when you're starting from the actual design files. And I just literally took the design files, ripped out all the other crap, and just kept the headers and the outline. It's like, well, not gonna mess that up. At least I know that I'm starting from that point, which is, if you get that wrong, that's a bad day to start with, right?
Yeah.
Jumping and cutting on the connector side of things.
And I think like a week or a couple weeks after it was launched, there was already boards showing up on Tindy. It's like, well, I want USB. Here's my 4-port hub design.
Oh, nice.
And so there's already mods being done on it.
Right. Well, there's money to be had. That's the thing. Like that's I am amazed by the low cost ecosystems that pop up. Right. Like Pi Zero, the Pocket Beagle, the ESP, just all the stuff around ESP.
Yep.
It's just that, it's not always clean and it's not easy, but damn, does it enable new things,
especially like when the ESP first came out, it was kind of amazing, all the little hacks they were doing.
Right.
It's like, then we got a whole library to use now.
Exactly.
We can do everything.
Now it runs
start
Lua.
off a couple hacks.
Right. It's like, wow, how? What? But it's great. It's really great. That is the collaborative internet-y thing because people want to do more stuff with it, right? So that's awesome.
And what we try to do, especially with the foundation of the org, is that if people start doing cool things, we try to pull in their projects, their libraries into the default image. It's like, this is awesome what you're doing. We want to show it by default.
Right. Yeah.
That's one of the things that happened in the Node-RED is we've been shipping Node-RED for a while. And they don't say, someone made this awesome module. We're talking to IO. It's like, oh, we need that by default now too.
Nice.
So we pull it in and share it with everyone.
Well, and you keep talking about pulling this stuff in too. So is there a cost to it in terms of just bits? Or how much cost?
For the longest time, our cost was it had to fit in 2 gigs of eMMC.
Okay.
And then we had 4 gig problem.
Okay.
But now with the Pocket Beagle, well, we're not going to run Xorg or Wayland because there's, we don't have a real display to connect to by default. So we can shove more in and still fit in that 4 gig target.
So you're just saying because there's fewer peripherals taking up that base space.
Well, like Xorg and any GUI interface is big.
Oh, I see.
So if we drop the GUI, our 4 gig images, we can fit a lot of other tools in there.
Okay, and
then ship it.
What is the 4 gig? No, why is it 4 gigs?
So the BeagleBone revision C is a 4 gig eMMC. And so we kind of put that as the max size we'll ever make an image.
Okay. Which seems doable, right?
Yeah.
Have you run into it or no?
Yeah, we could fill it up pretty fast.
Okay.
If we really wanted to.
Okay.
If we put every library that was ever created, yeah.
Okay. So there is some cost to it, but you're saying that because of these images for the Pocket Beagle, there's just more space to start with, so it's a why not right now.
Yep.
Is there a process later to be like, well, we got to get rid of this thing?
The process is, does it still work?
Oh, well, okay. So they kind of age out on their own.
Yeah, kind of age out. Like we've had a couple libraries that were tied to the 3.8 kernel that we don't use by default anymore, and it was only tied to that kernel.
Got it. Interesting.
And a lot of times too, they're implemented in other softwares. Like, well, you just use this library instead.
Like the functionality was done elsewhere?
Yeah, it was a similar functionality. It just was a different name.
Oh, okay. So to talk to the similar peripheral or something like that?
Yeah.
Okay.
In this case, it was talking to the PRU in that version. Like we had a better way to do it. So.
Okay. Well, okay, so you're at DigiKey, right? So
Yep.
are you seeing people I mean, not that you're like watching this like a hawk, but I mean, y'all do sell these chips, right? So like obviously people can go and buy these and plop them onto boards as well, right?
Yep, and I see it from both sides. Where like it's like buy this chip. They've already spun a board. Like we have a problem. We can't get this talking. Like so, I see on the big debug side of the first couple PCB designs.
Oh, interesting. Okay.
It's like we want to do this bring up.
And that's
So I see
and
a lot
they
of
get
that.
they get to you, huh?
Yep.
Right. Oh yeah, maybe we should say what you do at DigiKey, huh?
Yeah, so I'm an applications engineer there, and I just basically support customers. And
Right. So this kind of like is a merging of all your loves, huh? This is
yep. It's like I get to go home and play with what I do, and go to work and do what I like to do. So
Oh man.
it's kind of hard to separate work from home some days. But
I know the feeling.
the only difference is at home I have more build farms.
Right. So what does a build farm look like for you?
Oh, right now it's 20 BeagleBone Blacks, about 7 WAN boards, 6 X15s.
What?
Yeah.
What are you doing? You just like, so are these like all just networked and you just kind of kick them off and they do their thing or what?
Well, the main thing that they're doing is, so yeah, we haven't talked about it yet, but we do weekly images. So when you go to beagleboard.org, it'll say latest image, and it'll say like 3 months ago.
Uh-huh.
Behind the scenes, we do it weekly.
Is that to do like, is that like a continuous integration type thing or what?
Exactly. We're doing continuous integration. We're doing kernel builds. So we usually do 2 or 3 kernel builds a week per version. So we get updates that come in from other customers, other users, from TI, and we just keep on integrating the kernel, all the package updates, and yeah,
So
lots of testing.
Is this really just that you're heating your house with all these small computers that are just crunching code all day? Is that the real plan here?
No, that's what the crypto miners are for.
You're right. I did hear someone talking about that. They're like, I heat my house with electricity anyway, so why the hell not? It's like, yeah,
exactly.
Yeah.
Well, when you live in the Northland,
Yeah, you got to get warm somehow.
when you have to open the window in the Northland to cool your systems in the winter.
Wait, seriously?
Yeah,
No.
the basement gets hot here.
Holy crap, that's amazing. Well, so you aren't running like a cooling system up to the rest of the house or what?
No, I just open the window.
But I mean, like, why don't you use that heat? Like, you're paying for gas or no?
Yeah, I pay for gas, but it's already heating up the house, but it's overheating the house.
Whoa, that's amazing. Wow, computing power, huh? Okay, so what? I guess what actually like determines it? Like, do you have a suite of tests then? How do you actually know if an image is good?
So one of the things that we do is long-term stability. We want to see how long a board will stay up, whether it's doing a load test or Wi-Fi. We want to make sure that even after a week that it's still up.
Uh-huh.
Because that's one of the things that we've always run into, that if it reboots before a week, there's something seriously wrong. If we usually get at least a week out of it, we know that when the end user gets it, it's going to last for days on end.
Right. So it's
We've had
it's
some
like a
in the-
bathtub curve kind of thing, right? It's like
Yeah. We've had some in the 4.4 that people have been running for a year and a half.
Oh wow. Okay.
And I had one here that was almost 2 years until the power went out for a day, and then my UPS has failed.
Oh, that's a
It's
shame.
like, darn it, I lost my uptime.
Right. That's like a really really slow marathon.
And when the Beagle first came out, that was one of the things I was doing. I was helping out the GCC guys by rebuilding GCC and running their test suite, because I found that it would take the board 3 or 4 days to do it at 100% CPU usage
Oh my god.
while going over the network. So it's like, if it stays up to do this test suite, it's doing pretty good. It got to the point where it just never failed, so I stopped doing it.
Okay. And what does that mean with the test suite?
So GCC has a huge test suite where you build GCC, which takes about a day, and then you run the test suite, which takes about 2 days. And it runs through all the test cases, pass or fail, and then in the end you get a big list.
Okay. And at the beginning, it probably is a lot of fails, right? And then later on, it's
Yeah, well, it's the way GCC works. It's almost like every bug they've ever had, they've made a test case for
oh wow.
in the 30 or some years in existence. So it's a massive test case.
That's some baggage, huh?
Yep. And so if it survives that, you figure, well, it's going to survive your average user who just has it idling and taking a sensor reading every once in a while.
Okay. Yeah, no, that is a good test, huh? Okay.
But nowadays the problem is the boards are so fast, the test suite's done in a day, so it's kind of worthless.
Okay. Yeah.
Don't you
hate how you keep getting all this computing power
days
for like cheap and awesomeness?
Yeah. It's like the test suite's too fast nowadays.
Yeah.
It doesn't actually test anything.
Right. Well, it probably heats up the house a little bit, right?
Yeah. But the ARM boards, they don't heat up the house very much. That's the problem. They're so efficient. Yeah. Where you'd have this big GPU heat up the whole room, but...
Yeah. So that was something I was going to ask Jason too. Like I said, we're sad that he couldn't stay with us, but this chip's getting a little long in the tooth, isn't it?
Yeah, it is. But with the PRU, it's still selling like a hotcake.
So it's just because of that? I mean, like, I guess...
that tells you how important it is, the PRU.
Okay. So, but the ARM v7 is the main... What is the core in there?
So, yeah, it's an ARM v7, and it's the Cortex A8 version of the Cortex F7.
Okay, so it's ARM.
And that was the first... so the A8 came out first, the A9 came out second, and then they went crazy and created a whole bunch more parts.
Yeah, right. Because I remember like A8, A9, that was like still like iPhone 4, 5, right? Like that's also what it was using.
Well, you think about A8 was so Nokia days.
Oh, am I that far back?
Nokia was the king of all cell phones. What they had was the OMAP 34 from TI.
Wait, I thought the A8, A9 was actually still around for a while as like as a consumer thing. Is that am I way behind the game here?
Yeah, I think you can still find them. They're harder to find nowadays.
Oh, okay,
Most days they're all 64-bit.
Okay, so I'm full of crap then. So I don't know what I was thinking of with the Apple stuff, but okay, so what is an example number now then? Like what are they using these days? So
the Apple ones are all 64-bit ones. I think the original iPhone was a Samsung Cortex. It was an A7, but it was, or was it an ARM9? It might have been ARM 11, so even pre-Cortex.
See, this is the thing that's confusing to me. So there's an A9, but a V7, V8, V.
So the way ARM works is you'd always have the ARM V architecture. So you had ARM V1, ARM V2, ARM V3, ARM V4, and so the ARM V7 variant is where all the Cortex families came from.
Okay.
Whereas the ARM V8 is now the new 64-bit stuff.
Okay.
And so then, before the Cortex came out, they had a couple products. One was called the ARM9, which is an ARM V4.
Wait, so wait, there's an ARM... Wait a second. There's an ARM9, there's an A8, and a V7?
Yeah. The guys in England really wanted to mess everyone up.
Oh my God. I'm going to go over there and punch someone in the nose. What is with the naming? That's terrible.
You got to go on Wikipedia and look up ARM architecture. And I'll show you a one-number list.
I will link people
list.
there. Yes.
Yep.
Oh my God. Okay, so that's really confusing. So, what would mess up your world the most is it like the V7? So this is an ARM V7 A8.
Yep.
So
the biggest thing that messes with us is whether it's so there's a revision of the core too. So the original Beagles when they came out 10 years ago were R1 PXs. So they were revision 1, and I think there was a P2 variant and a P3. And nowadays they're all revision 3 P something.
Okay. So wait, R1 PX was the original.
Yep.
And then now
it tells you it was the first revision.
Uh-huh.
It was basically the first Cortex A8 that ever came out, whereas the newer ones are like the third revision. So lots of bugs in the old stuff.
Okay. Well, I mean,
which
it happens,
surprisingly, one of those old bugs fixes Spectra in Meltdown for us. But
take that, Intel.
Yep.
Yeah, different kind of realm of things. But okay, that's good to know. I was actually listening, so if people heard me floundering trying to talk about it last week, I then listened to Embedded, and they had someone on who actually knew what they were talking about, and that was much better. Oh, it was Exploding Lemur from Twitter. I forget, Nick, I think. But I'll link that as well, where they actually talked about it. So they talk about Spectre and, what is it, Spectre and...
yeah.
It's not Heartbleed.
Meltdown,
yeah. That's it, yep.
Yeah.
Okay.
Yeah, I think you teach a whole couple of graduate courses on that stuff
now. Right. That's crazy.
And people still don't know what's going on.
Right. So this was a good explanation. So I will link people there. Okay, so you had to switch, though. So what happens then when it goes from R1 to R3? What change? Is it like the compiler changes, or what changes here?
Well, one of the big things that was happening in the ARM world, everything was getting recompiled for Thumb 2, which is...
Wait, there's another number?
yes.
Oh, no.
Thumb 2 allows more optimized code. It's both 16-bit and 32-bit instructions in the call stack.
Okay.
And the R1 family had lots of Thumb bugs, so...
Okay. And Thumb versus Thumb 2. God, their naming is terrible. It's really bad. Okay, so...
Yeah. They were having fun, though. You have an ARM processor with Thumb mode.
Oh, okay. That's kind of clever, but like just the appending of numbers, that's the bad part. You know? Like, why not call it fingernail? I don't know, or pinky, or, you know, anyways.
If you look at the 64-bit stuff, it's now worse. They have ARM v8.1, ARM v8.2, ARM v8.3.
Yeah, that's crazy. Okay, so you had to go and... So when it went from Thumb to Thumb 2... What did you have to do then? Like, do you have to go and like recompile everything, or what happens?
For the kernel, there's a lot of changes we had to do, and we found out very quickly that Thumb 2 broke a lot of stuff.
Okay.
So that's one of the reasons why when you go to the BeagleBoard.org, there's an XM image for the old BeagleBoards, and then there's a Bone image for these, for the newer stuff.
Okay.
One of the big changes is that all the Bone stuff for the BeagleBones have Thumb 2 enabled by default.
So XM, why didn't XM take that on? Is it because it's just the processor's on board?
The processor on board, and if we enabled it, we'd lose performance and other things would break, whereas the Pocket Beagles would handle it just fine.
Okay. Just because they're lower performance in the first place? Or?
Yeah.
Okay.
They could actually understand that instruction without problems, without workarounds.
Okay.
Errata.
Got it. Man, that's crazy.
And that's one of the things we had to enable. It's like, okay, we have a single core Cortex A8. We have to enable Thumb 2 because we need every performance we can get out of the core at this point.
Yeah. I think this just really, really reinforces like just the layers and layers and layers of abstraction that happen. You know, there's just so much stuff that I don't have to think about, which is great, like really great. I never want to think about this ever, and you're a saint for doing this stuff.
Yeah,
and Jason is too. You know, yeah.
It's like we try to make it as easy for everyone else. Like it's just all the stuff to make it fast is enabled by default.
Right, that's great. So Thumb 2 broke a lot of stuff. You had to just go like bug fix at that point. Is that the idea?
Basically separated the two. It's like,
oh, okay.
So we have Thumb 2 enabled for this device. This device does not get it. Don't run these images.
Okay. And then, so kind of going, is this kernel stuff? And my brain is starting to slow down, and we should probably end the show soonish. But okay, so
a lot of it is on the kernel side.
Okay, so like that's what I'm wondering. Is like so when it said you broke a lot of stuff, does it break the peripheral things too, or just the internal, like talking to from one thing to another? Question may not have made sense.
It would slowdowns, and you get undefined instructions, and you get erratic behavior.
Okay.
So yeah, breakage, lots of breakage.
But you fixed it, so that's good.
Yeah, we fixed it on the older parts, and like just don't run these images with that.
Okay. But like you said, so you said that these builds come out quarterly. So
yep. So we have two separate builds that go on. We have a monthly build for Jesse, which we consider the old stable at this point. Okay. For Stretch, we have builds every Sunday morning, and they get pushed out Sunday afternoon. So every Monday, you'll see me update a wiki page. Like, here's the latest images for this week.
Like what it fixed and what's new about it, whatever.
Yeah, I don't bother showing what it fixes anymore. It's just a rebuild of all the new packages.
Yeah, just use it and be happy. Don't ask questions.
Yep. And that's one of the things is, people ask, well, how do I get they want to get network connectivity to their Pocket Beagle to just update the software. It's like, just go to the website, download the latest version. You have it as a updated Sunday. And it has all the kernel week's fixes from the week. It has all the U-boot fixes from that week.
Got it.
And so it's just continuously integrated.
Okay, no, that's good.
Our disconnect is how often we convert that weekly image to, hey, here's the latest image.
Right. So, and that's a good question too. So if someone's going to, a lot of people, if they're just thinking about doing this, what should they go and pull down as their first thing for the Pocket Beagle?
So the first thing that all they need to do is just turn it on, the Pocket Beagle.
But no, I mean, which image though? Is it shipped with?
That's right, because I keep forgetting there's no image by default.
Right. It's the SD card, right?
Yeah, because the older boards, you plug it in, and it'll actually tell you a website. Go to this website, FAQs, and then you go to that website. Hey, there's the new image.
Right. So they grab an SD. I don't think it ships with an SD card, right?
Yeah, it doesn't ship with an SD card.
Right. So
there's a good utility called Etcher.io that is multi-platform.
Yep.
It's solved all the Win32 problems.
Yep.
It solved the Windows, Linux, Mac is different.
Yep.
They're awesome guys at Resin.
Yep.
They also have their own image for the Beagle too.
Oh, cool. Okay. So it's best to start with the Jesse stable though, or which one?
Depends.
Just give me one, man.
I tell people to run Buster right now.
Oh God, is that the newest one?
That's the one that's going to be coming out in a year and a half from now.
No. Don't do. Okay, never mind.
Yeah.
Don't listen to this guy. This is like this is like when you walk up to a Linux guru and you're like, "Hey, what is that interesting thing on your laptop?" They're like, "Well, let me tell you."
Let me tell you. Yeah, this is the newest and greatest, and you'll have it next year.
Right? Why don't you take a seat and I'll show you how to do this from source.
Exactly.
Oh,
show all the use flags. You can build it yourself.
Okay, so
yeah,
I'm going to say the Jesse stable then.
Stretch stable is what we've been telling people to do right now.
Okay, that's good.
Because Stretch is stable. Jesse, we're not going to do a lot of changes to it. It's kind of frozen. So if you have something that you don't want things to change, use Jesse.
Okay, and
so the Stretch, we're still backporting things.
So the Stretch stable though, what would be the default kernel to? Because now I know that's a different thing.
Yeah. So in Jesse right now, we're shipping 4.4 by default. We're not going to change it ever. Okay. It's done.
Yep.
Stretch, we're at 4.9 right now.
Okay.
I'd like to get it to 4.14 in the next month or two.
Okay. That's good to know. And that will enable some of the you said like the network connectivity stuff and maybe the mesh stuff, right?
Yeah, the biggest thing is mesh networking is going to be better. Problems of Wi-Fi mesh, we don't have a good version of the WPA supplicant and the host AP package yet to take full advantage of that. But the kernel's ready.
Cool. Okay, so last question. Where do people go to find other people to help answer questions?
The easiest thing to do is just search BeagleBoard group into Google. There is this massive forum / email list that has been going for 10 years.
Okay. It's like so Google every Groups question, or something? Or?
Yep, Google Groups. It's the BeagleBoard project.
Okay.
Yeah, it's been going on for 10 years now. Tons of people have been on there.
Flame wars abound.
Yeah, flame wars from every era.
10 years, man. That is very impressive, actually.
Yeah, there's a lot of historical stuff in there. You can go back and what was 2.6.11 like on the board?
Right. I guess that's what's amazing.
What was it like before Thumb? What was it like before ARM optimizations?
There's your weekend plans right there, folks. I mean, come on, just go listen to all that stuff. That's great. Yeah.
Make sure to bring out your pitchfork and magnifying glass to look at the Arcadillo.
That's right. Oh man, yeah. Then use your historical stuff against you at some point, right?
Yeah. And
Robert, you said this back in May of 2009.
Yeah, and you'll see people that worked at Nokia, then moved on to TI, then went to like Trolltech, and then they went back to TI, and then they went back to Intel. You see people move all over the place through that email thread.
Did you say Trolltech?
Yep, Trolltech. There were some Trolltech developers. Then Nokia bought them.
Trolltech is just like perfect for an online discussion group, though.
Oh, that's why there's a troll group.
That's great. Okay.
Yeah. Because otherwise, there's the IRC channel too. There's
so that's good to know. Yep.
Yeah, Beagle on Freenode.
Okay. Beagle, great.
Of course, I'm never on there, but so we'll let other people answer those questions.
IRC is its own beast. I recently had to go back on, and I'll probably be back off again. It's just one of those things,
You have to go on there also. It's like we have Google Summer of Code starting again, and I'll have to be on there again. So
right.
Take care of those students.
Yep. You're doing good work for that. But you're doing good work for all this stuff. You and the whole team. Like I said, I never would have gotten close with any of this stuff. So I feel personally enabled by all these projects that are out there. Like the fact that there's Linux computers that are running just a single circuit board is insane.
Yeah, a single-sided circuit board in some cases.
That's true. Right.
I'd still like to see someone actually do design where that Octavo chip, there is a way to do this one-sided board.
That's right, yeah, because it can escape and
it is set up for that, but I haven't seen anyone do it yet. So
challenge accepted.
It'd be a good one to see on one of the blog sites.
Right, you need to see it, and it needs to be like milled, right?
It has to be available on Tindy.
Right, exactly. Just wear it around your neck as like a talisman.
You gotta prove it works, and then prove you can make it, and we can buy it.
Right. What about you? Are you on the Twitters or anything like that?
I'm mostly on the BeagleBoard groups, and then I'm hiding behind IRC. If you ask enough questions, eventually I'll answer.
Okay, so you're there. You're just.
I'm usually
lurking.
hidden.
Yeah. Okay, that's healthy, but no public facing Twitter type thing.
No, I like to hide.
Okay, like to hide. You know what? You got your server farm. You've got your whatever you called it, your build farm.
Yeah, it's like they find me on GitHub. I get hundreds of emails a day, so it's like I try not to be
Seriously?
Hey,
Oh, I guess all the updates and everything. Huh?
yeah, it's like, hey, we need this. You broke this. Fix this.
Right. All right. Well, we will definitely post links. I will be posting links to all this stuff. Everything I can figure out. I'm gonna have to listen to this whole episode again too, and be like, what were we talking about?
Yeah, because the good thing is we have a link somewhere for everything.
Yeah.
The problem is we don't remember where it
the
is.
organization, right? Yeah.
Yeah, because when you have 10-year-old project, you have links going everywhere.
That's right. Yep. Well, Robert, thank you very much for
You're welcome.
being on the show. It was a pleasure talking to you. I'm sorry Jason had to go, but we enjoyed talking to him again too, and we'd love to have you back sometime.
That'd be awesome. Pleasure talking to you guys too.
Okay. Well, we'll talk to you soon.